Solve each system by substitution. So y equals negative 4x. That means I can replace y with that negative 4x. I'm going to take this equation and write negative x minus 2, but instead of y, that's where I'm going to replace it or substitute it with negative 4x. Finish the equation, equals 7. Now I'll have a new equation with only one variable x that I can solve. So bring down the negative x. It's not touching parentheses, but that negative 2 is touching instead of parentheses, so that gets multiplied. Negative 2 times negative 4x is positive 8x. Keep the equal sign and the 7. Negative x plus 8x are like terms, so I can combine them, and that combines to be 7x, which equals 7. Dividing both sides by 7, I get x equals 1. I need to substitute that back into one of my other equations to solve and find y, so I can find my point. So I had y equals negative 4x as my first equation right up here. And if x equals 1, then I can replace x with 1. So negative 4 times 1 is just negative 4. And my x value is 1, my y value is negative 4, and that's my solution, which is B. Okay, 33. Solve each system by elimination. I'm going to rewrite that over here. 3x minus 6y equals negative 9. X plus 6y equals negative 11. So when you eliminate, you add up your two equations, make sure everything's lined up, x, y, equal sign, number, and you add them up to try and make something eliminate, meaning it adds up to be 0. So my x's don't add up to be 0, but if I look at my y's, they have opposite coefficients. One is negative 6, one is positive 6. So if I were to add those up, I would get a 0 there, and I wouldn't have a y at all, which is what we want, so we have a simpler equation that we can solve. So 3x plus x is 4x. Negative 6y plus positive 6y is 0, so we don't write anything down. Bring down the equal sign, and negative 9 plus negative 11 is negative 20. Next, we're going to divide both sides by 4. And we get x equals negative 20 divided by 4, which is negative 5. Again, we need to substitute that value back into our equation. Go into either one. I'm looking at these two, and I'm seeing that the second equation looks a lot simpler. So we have, instead of x plus 6y, negative 5, plus 6y equals negative 11. And then we can add 5 to both sides and bring down the 6y and the equal sign. Negative 11 plus 5 is negative 6. Now I can divide both sides by 6, and I get y equals negative 1. So my final point, x is negative 5 and y is negative 1. That matches up with B. Okay, number 34. We want to sketch the solution to each system of inequality. So graphing these like they were in slope-intercept form, but we have to pay attention to where we have solid or dotted lines. And I know in the video this is hard to see where the shaded regions are. So this is one shaded region, this is one shaded region, that's a shaded region, and that's a shaded region. It will be darker and more clear on your final that we've copied. All right, the first one, I see greater than, which means it is dotted, and it should be shaded above. The next inequality symbol is less than or equal to, so it should be solid, and it should be shaded down below. Okay, for the first one, I have a y-intercept at 0, negative 2, and a slope of 5. So I'm going to find any of these that first have a y-intercept at 0, negative 2, and I'm going to write that out here. And slope of 5. So here is a point at 0, negative 2. So that y-intercept checks. I want to see if it also has a slope of 5. So if it has a slope of 5, I should be able to go up 1, 2, 3, 4, 5 and write 1. But that actually doesn't work. So that y-intercept and that slope do not match this graph. So that one's going to be out. I can also look at this and I notice that while I should have one dotted and one solid line, these are both dotted, so definitely cannot be A. I can also look at C and quickly rule that out. These are both dotted, but I should have one dotted and one solid, so I can also quickly rule that out. If I look at B, well, those are both solid, but I should have only one solid and one dotted, so I can also rule that out. Now, you won't always be able to rule out 3 of the 4 graphs just by whether they're solid or dotted, so you want to know how to check for the other things. So here I have a y-intercept at 0, -2. I'm going up 1, 2, 3, 4, 5, and right 1 to my next point like I should. So the y-intercept checks out, the slope checks out. It is dotted, and if I look at where it's shaded, if I go straight up, that's the side where it's shaded. So it is shaded up above. So that whole first one checks out. If I look at the second one here, I should have a y-intercept at 0, 2, and I should have a slope that is +1. So if I look at the other line here, it does have a y-intercept at 0, +2, and it does go up 1, right 1, just like the slope says. It is solid like it should be, and if I go straight down, it is shaded down below it like it should be. So everything checks out. The second inequality is as well, and I know my answer is D. Okay. The next one, number 35. Match the correct system of inequalities to this graph. Pay attention to solid or dotted lines and your slopes. So here I can't just look at this and rule out something by the inequality symbols. I really have to be careful here because I have a dotted line and I have a solid line. So I should have an inequality that has an or equal to, but I should also have an inequality like this that does not have an or equal to. Well, that has one of each like it should. That has 2 dotted, which this doesn't have, so I know that's out. That has one of each, and that has one of each. So just looking at dotted and solid, only ruled out 1 in this case, not all 4. So we have to dig a little bit deeper. And this is the region where they are overlapping. Okay. So let's look at the solid line. The solid line has a y-intercept at 0, 3. So I'm going to jot that down. I also need to find the slope of the solid line. So here are some other points. And if I look at those, my slope is going up 2, right 1, up 2, right 1. So up 2, right 1. If I were to reduce that, +2 divided by +1 is 2. Now it is a solid line, and from that solid line, the shading is below. So solid and shaded below tells me I have a less than or equal to. So y would be less than or equal to that slope 2x, and then the y-intercept plus 3. So I know that's one of my problems right here. The next one, my y-intercept is at the point 0, -2. And if I try to find my slope, I need another point. And it's a little harder to see when it's dotted, so you really want to make sure you have a good solid point. And I think there's one here. Looks like there's one here. Just make sure you're actually getting the right points. And I can tell here, okay, those are evenly spaced out. Those are good points. So I can tell it's a negative slope. We're going downhill. So I'm going down 2 and right 3. Down 2, right 3. So my slope down 2, right 3. So I'm going to have -2 over +3 just reduces to -2/3. So that's the slope I'm going to be using. It's dotted and it's shaded up above. To be dotted and to be shaded above, we would have a greater than symbol. So y is greater than that slope, -2/3 x, and then our y-intercept, that y value is -2. So I'm looking for both of these. I can see on A, I have y is greater than +2/3 x minus 2, so that slopes off. If I also look at this one here, y is less than or equal to -2x plus 3. It's close, but that slope is off, so it's definitely not A. I go on to C. I have y is greater than or equal to -2/3 x minus 2. Looks very similar, but I need a greater than. That's a greater than or equal to, so that's off. For my other one, it also looks very similar, but I needed less than or equal to, and this has a less than, so that's off. So it should be D, but we want to double check and make sure we haven't made a mistake somewhere. So on D, I have y is greater than negative 2/3 x minus 2. That one checks with what I have. And y is less than or equal to 2x plus 3. That is also what I have. So then we know that we are okay. All right, next. Simplify each sum. Sum is what you get when you add two or more things together. So we're adding here. I'm going to rewrite this out. 4n plus 4n cubed plus 5n squared plus 2n cubed minus 4 plus 8n. So, this is better. There we go. Okay, so since I have parentheses, I have to look and see if I'm multiplying anything. These parentheses are not touching, so they are not being multiplied together. There's just a plus sign in the middle. If you were trying to think of what you would need to distribute into this set of parentheses, the only thing outside here that we don't see is a 1. So you're just distributing a positive 1 into that polynomial. But we all know that anytime we distribute a 1 or multiply a positive 1, it doesn't change anything. So I'm just going to rewrite the problem without parentheses. 4n plus 4n cubed plus 5n squared plus 2n cubed minus 4 plus 8n. And once you rewrite it, the only thing you have to do next is combine like terms. And start with the largest exponent. I have a positive 4n to the third power and a positive 2n to the third power. Add up those coefficients. Positive 4 plus 2 is 6, and n cubed stays the same. So we're going to cross those out. Next, I have a 5n squared into the second power. Nothing else has an n to the second power, so I'm just going to write that down as it is and cross that out. Next, I'm looking for my variables, n and n. 4n plus 8n is 12n. Add the coefficients, but leave the variables the same when you combine like terms. And last is just the number negative 4. So this is what I'm looking for. They all start off with a 6n cubed, so that's fine. Next should be 5n squared. So A works. Let's check the rest of it. Next should be positive 12n, which it has, and next should be negative 4, which it has. So we see, okay, our answer is A. All right, 37. You have to remember our laws of exponents. Anytime you have something to the 0 power, that's just the number 1. Anytime you have a negative exponent, you write that base with the exponent on the other side of your fraction, and you write a positive exponent when you do that. If you are multiplying the same bases, like x to a power times x to a power, you add the exponents together. If you are dividing the same bases, like x to some power divided by x to some power, you just subtract the exponents and you do the larger exponent minus the smaller exponent. So that's what we're going to work on here. I have a coefficient of 4. It's the only coefficient in the whole problem. So imagine I cover up everything else. What do I see? A 4. Well, so what am I going to write down? A 4. That doesn't change. I'm going to cross it out now that I've used it. Okay, next I'm looking at my x's. I'm going to look just at the numerator first. I have x to the 4th and y cubed. Those are different. I'm just going to go ahead at first and write those down as well, because I see that I have some things in the denominator that can be worked out. So we're going to do that first. Okay, I have x cubed here and x to the 4th here, and I see that we're multiplying. So remember, when you're multiplying the same bases, you add exponents together. So I have an x, but I have x to the 3rd and x to the 4th. That means I'm multiplying x by itself 3 times. I'm multiplying x by itself 4 times. Altogether, you're multiplying x by itself 7 times. That's why we add those exponents up. Now you see here, I have a y to the negative 3, but I have a y. This y, I'm just going to write down where it was and cross that out, because you have to do something anytime you have a negative exponent, and that's write it on the other side of your fraction like a reciprocal, but instead of y to the negative 3 up at the numerator, you write y to the positive 3. Now you can finish working this out. Okay, now I have a lot of y's, so I'm just going to focus on the y's for a bit. And I'm going to leave everything else
where it is, and I'll deal with the x's later. So my y's, I have y cubed times y cubed. I'm multiplying y by itself 3 times. I'm multiplying y by itself 3 times. Altogether, you're multiplying y by itself 6 times. Okay, now this looks a lot smaller and easier to work with. We're going to be dividing these variables in their exponents. 4 is still the same. And we know when we're dividing and we have exponents, we subtract the exponents for those bases. So I'm looking at x to the 4th over x to the 7th right here. And I see 7 is bigger than 4. So I'm going to do 7 minus 4, which is 3. But I'm not going to write x cubed up here. I'm going to write it in the denominator because that's where the larger exponent was located. Okay, next, I have y to the 6th over y. And anytime you see just a variable, the exponent on it's always a 1. So 6 minus 1 is 5, and 6 is larger, it's in the numerator. So y to the 5th is also going to be in the numerator. And it's several steps to get that final answer, 4y to the 5th over x cubed. And now I can see my answer is D. Okay, 38, find each product. We have to remember to distribute. X minus 2 times 3x plus 7. Anytime you have a binomial multiplied by a binomial, you're going to have to distribute or multiply 4 times. So starting with the x gets multiplied by 3x, but the x also gets multiplied by 7. So x times 3x is 3x squared. X times 7 is 7x. And then that x has been dealt with. Next I have the negative 2, and the negative 2 also gets multiplied by both terms over here. So I'm going to do negative 2 times 3x, but I'm also going to do negative 2 times 7. So negative 2 times 3x is negative 6x, and negative 2 times 7 is negative 14. Now I would be finished, but as I can see, there are no answers here that match what I have, and that's because you have to combine like terms. I have an x and an x, those are like terms, they have to be combined. So I'm going to write the 3x squared. 7x minus 6x is 1x, or just x, and I'm going to bring down the negative 14 here. If I look at all my options, I can see here I have a 3x squared plus x minus 14, just like what we just got. Okay. All right, next we're going to look at number 39. It says, factor the common factor out of each expression. So we're looking for the greatest common factor here, what these two have in common. So I see 20p cubed and 12. I'm going to write that down. They do not share a variable. So I know a variable, the p, that's not going to be divided out of this. But 20 and 12, they do both share 2. So I have to decide, is 2 the largest number that goes into both of those? Well, 2 does go into 20 and 2 does go into 12. Let's think bigger. There's 3. 3 doesn't go into 20, so I'm going to go one larger and say 4. Well, 4 does go into 20. 4 also goes into 12. That's a little bit bigger, so that's nice. There's a larger number. Past 4, there is 5, but 5 doesn't go into 12. There's 6. 6 doesn't go into 20. 7 does not go into either of them. 8 doesn't go into either of them. 9 doesn't go into either of them. 10 goes into 20, but not 12. And 11 doesn't go into either of them. 12 goes into itself, but not 20, so I'm kind of maxed out on my numbers here. The largest number that went into both of them evenly was 4. So we're going to take a 4 and we're going to divide it away from both terms and write what's left. So I know this is going to have a p cubed because it already had a p cubed. So I have to figure out the coefficient. 20 divided by 4 is 5. 12 divided by 4 is 3. And the way that you check your work is you distribute that back in and make sure it matches. 4 times 5, p to the third power, is 20p to the third power. That checks. 4 times 3 is 12. That checks. So we know this is going to be our answer. And we can see that right here on option A. All right, number 40, factoring out another GCF. Negative 6x cubed plus 10x squared plus 6x. finding a greatest common factor. First, I'm going to look at the variables x cubed, x squared, x. They all have an x. That only has an x, nothing bigger, so that's the most that I can take out. But I am going to be dividing an x out of all of this, so I'm going to go ahead and write that on the outside. Now I'm looking at my numbers. -6, 10, 6. 2 goes into all of those, so it could be a 2. 3 doesn't go into 10. 4 doesn't go into any of them. 5 doesn't go into any of them. And then I hit 6, which I have and can divide out of itself, but 10 is not evenly divided by 6. So 2 is the largest coefficient, so we're going to divide out of 2. So -6 divided by 2 is -3. If I'm multiplying x by itself 3 times, but I divide 1 out, now I'm only multiplying x by itself 2 times. 10 divided by 2 is 5. If you were multiplying x by itself twice, but you divide 1 out, you're only left with one of those, so x to the first. 6 divided by 2 is 3, and if you had an x but you divide it out, well then you don't have one anymore. So this is the answer I'm looking for, right here. 2x times -3x squared plus 5x plus 3. All right, factor completely means you always want to look for a GCF first. You might have one, you might not. N squared, -2n, -80. They don't all three have a variable. They also don't all three have a coefficient in common, so there is no GCF here. So when that's the case, you have to set this up. You're going to have two binomials that multiply to be this trinomial. The only things that multiply to be n squared are n and n, so that's how it's going to start off. And then if you remember back to factoring, we're always looking for two numbers that will multiply to be what's on the end and will add to be what's in the middle. So we're going to make a list of possible combinations there. So things that multiply to be -80. There's -1 times 80, +1 times -80, -2 times 40, 2 times -40. 3 doesn't go into 80, but 4 does. So there's -4 times 20, +4 times -20. 5 will go into 80. So there is -5 times 16 and 5 times -16. And then 6 doesn't go into 80, 7 doesn't go into 80, but 8 does. So there's -8 times +10, +8 times -10. 9 doesn't go into 80, and then once I hit 10, well, I've already hit that number, so we're going to pause there. Okay, now from all these numbers, I'm looking for the set that will add to be the -2 that I had in the middle. Those don't add to be -2. These do not add to be -2. These do not add to be -2. These do not add to be -2. These two sets, this adds to be +2, so close but not quite. This adds to be -2, which is exactly what I have in the middle. So that means I'm going to have a +8 and I'm going to have a -10. And I can see that option right there on A. And the way you check is you distribute. So n times n is n squared. N times -10 is -10n. 8 times n is 8n. And 8 times -10 is -80. If you combine those like terms in the middle, you get -2n. And that matches up with the original problem, so you know you're right. Okay, the next one. Starting off with an x and an x. I'm looking for two numbers that multiply to be -20, but add to be +1. So numbers that multiply to be -20. There's -1 and 20. 1 and -20. -2 and 10. 2 and -10. 3 doesn't go into 20, but 4 does, so -4 and 5. 4 and -5, and then I've hit all the possible numbers that I can. So I'm looking for the set, -5, looking for the set that will add to be +1 in the middle. Not that, not that, not that, not that, but -4 and 5. Those add to be +1, which is what we need in the middle. So I need a -4 and a +5. And I see that right there in option C. The way you check is to distribute. X times x is x squared. X times 5 is 5x. Negative 4 times x is negative 4x. Negative 4 times 5 is negative 20. Combine like terms in the middle. X squared plus x minus 20, and it does check.